Okay. Now we have a square here. The length of each side, slide down. The length of each side of a square measures S inches long. Here's our square. Each side is S inches long. The area of the square is 49. We want to find the length of one side. Now, you may already know it just based on the math that you've already learned. But let's go through the thought process here as we break down this problem. So how would I find the area of a square? I can multiply, good, the length times width. For this square in particular, what am I multiplying?
S times S.
You're going to multiply S times S. Now, is there a way that I could rewrite that expression with an exponent?
S squared.
S squared.
I was thinking that.
Now think about what we call that exponent sometimes and the shape that we're talking about now. We'll compare those a little bit tomorrow. So now I have S times S, S squared, is the area. And I know that the total area is 49. Can I represent that as an equation? Like to solve and actually figure out the side length? What equation could we set up to actually solve and find the length of the square side?
49 with S squared.
Yeah, so we could do S squared equals 49, or like you said, Kate, 49 equals S squared. Absolutely. Now let's talk about factors of 49. What if I was going to figure out the answer to this problem? What do I know about S?
They're all the same.
S has to be the same. Like it has to be the number that I multiply by to get the area has to be the same because it's a square. Right? If it was a rectangle, it could be different. But I know specifically that this value has to be the same. So let's say, we're going to take about a minute. Let's say your friend is answering this question. And they're like, I already know the length of the side is 24.5 because S squared is 49 and half of 49 is 24 and a half. So I know that if I solve this, I know that the answer is 24 and a half. Do you agree or disagree? And if you agree, why? If you disagree, why? Turn to the people around you for a minute and try to come up with an agreement or disagreement with your friend. This.
Hey, Fred, you're the one who said that.
What?
Friend, I disagree with you so heavy it's not even. You're asking. Why wouldn't I be using it? Why wouldn't I just give it back to you? Ask for a pencil when I give you your pencil. No, I got mad at you for no other than a pencil in your feet. You had my pencil.
Okay, who wants to share what they came up with? If your friend said that, do we agree or disagree?
Disagree.
Disagree. Okay, why do we disagree?
If you square 24.5, you're not going to get 49.
So if I thought that this was 24.5 and I went to prove it, does 24.5 times 24.5 equal 49? No, so that's a problem. Anybody else have further explanation to why they disagree? Okay. Now let's say you needed to explain the difference between these two equations. You have 2s equals 49 and s squared equals 49. How could you explain the steps to solving them? How could you compare the steps to solving them? Take a minute, and with the people around you, have a quick conversation about solving both of those equations. Are you solving them the same way? Are you solving them differently? Are the equations the same? Are the equations different? Discuss.
Excuse me, Ms. Caravano?
Hi.
Hi, can you please send Jordan down to guidance?
Yes. She's on her way.
Jordan's absent.
Thank you.
You're welcome.
You can't make me.
Head down in the office. Okay, who wants to share how we would 2s equals 49. Okay, so if I wanted to solve 2s equals 49, and I wanted to solve it for s, how would I do that? What would I do to get s by itself?
Divide by 2.
Divide by 2. Yeah, and we would divide by 2, so s would equal 24.5. Cool. How about this one? Divide by 2? No. No, this one's a little bit different. What are you doing if you're solving that one?
Divide by.
So you're all saying the process. It's so tough to talk about what exactly you're doing. In order to get 49 here, we multiplied a number by itself. So in order to find that solution, I hear you when you say division, because in my mind I'm like, you really are dividing. But it's hard because you're not dividing by a specific number. You're figuring out what two numbers, the same number, times itself. What number times itself would give me 49. So the first and most important part when we talk about exponents here is that we understand that these two equations are very different. Right? The one on the left is requiring you to divide by 2. The second one is requiring you to do something very different. Okay? So here, these are our perfect squares. You have these written down from before the holiday, so you do not need to write them again. But what we're talking about today is the idea of solving an equation with a number like this. As you've solved equations, you always talk about inverse operations. If something's being multiplied, the inverse would be to divide. If something is being added, the inverse would be to subtract. The inverse operation of squaring a number is what? Finding the square root. So finding the square root is the inverse of solving a problem like this. Like if I needed to solve it, I'm finding the square root. And we'll take a look at this symbol here. So the inverse operation of squaring is finding the square root. The square root is any number that you can multiply by itself to get your original number. Now, if you don't already have that definition written, you can write it. If you feel very comfortable with that definition and you understand what it means to find the square root of a number, you don't need to add it in. This symbol here, which we're going to define in a little bit more detail tomorrow, is what tells us to find the square root right now. If I saw the square root of 9, that would be this. The square root of 9, and we know the square root of 9 is 3, because 3 times 3 is 9. Now, is that the only number that represents the square root of 9? What other number times itself would give me 9? No. I'll give you a hint. What other number times itself would give me positive 9? Negative 3 also. Right, and you can see that here. Another square root of 9 is negative 3 because negative 3 times negative 3, negative times a negative, would give you a positive 9. If you saw that as a solution, the square root of 9, you would see it written as this. That positive negative symbol stacked like that would represent it being a positive or a negative. And you feel free to use that symbol when you're showing square roots or any type of roots that we calculate. The only time you may not want to is if we're talking about a real world problem. For example, if I was putting up a fence and I wanted to find the length of the fence, you wouldn't say positive or negative. Why not? Because you're not going to have a negative fence. A lot of the real world examples tend to only focus on positives. Yeah.
Who made that? Like, who
The
made
tic-tac-toe?
that? Yeah.
I don't know. I found it online as just a resource for students as they were working on multiplying and dividing positives and negatives, and I liked it. It was easier for me to figure out and remember. So coming back to our original problem, if I was going to solve s squared equals 49, I'm not dividing by 2. I'm actually finding the square root and determining which number times itself gives me 49, and that would be 7. Now, negative 7 would count here, but since we're talking about a square, let's think it's an actual object. We'll say positive 7. Now, we can write, and this would be the algebra extension. Exponents can be rewritten as fractions. You've seen some of these in the textbook. Last week, you did a few of the problems in the textbook with properties of exponents, and they had fractions in the exponents. So 3 squared, okay, 3 squared is 3 times 3. Which we know equals 9. So we can write the same expression using a rational exponent. Okay, so 9 to the 1/2 power. and this is stuff that you'll add to your notes because this is new. 9 to the 1/2 power. So the equation of 9 to the 1/2 equals b indicates b, this number here, is the number that when I multiply it by itself this many times will give me 9. So we'll go through what that actually means here. Because this is a property. So 9 to the 1/2 is 3. Write that example down. 9 to the 1/2 power is 3. Because 3 times 3 is 9. So here is our property. In general, if I have a value raised to the 1 over m power, again, the a and the m are just meant to be random numbers right now, like any number. A to the 1 over m equals b. It means that b multiplied to the m power will equal a. I'll rewrite it. So a good example would be 9 to the 1/2 equals 3. I'll put some other examples up. That whole thing should be written down. I know. Just kidding. What would 36 to the 1/2 be? 6. Because 6 squared is 36. How about 12? And again, because this number to this power equals 144. How about this one? It's 2. Because this number to the 3rd power would equal 8. And you could rewrite that. If I had 8 to the 1/3 equals b, right? That would be b to the 3rd equals 8. And what number to the 3rd power is 8? That number would be 2. Anyone come up with any others? You want to come up with?
Why is it like 1/2 and what we said first? Why does it look like a 1/2?
It is, because it is a 1/2. Yeah, it's a rational exponent. So the fraction, the way that this breaks down, what we do with rational exponents, we can rewrite them. Tomorrow we're actually going to work on rewriting a rational exponent, which means an exponent that is a rational number or a fraction. We're going to rewrite them tomorrow with a radical symbol. We're actually going to simplify them to a radical symbol. And right now we're just starting by finding the equivalents. Okay. So 625, is there a number times itself 3 times? That would, wait, is that what I wanted to do? No. Yeah, this would be 25 because 25 squared is 625. Okay, you'll see some practice problems for this, but we're going to try a few. 81 to the 1/2, what is it? 9. 144 to the 1 over 2? 12, oh, we did this one already. 2. Now, we can take this to one other level, one smidge farther. Okay, we can have expressions that are grouped. Okay. Now, the reason we can do this, bear with me for one quick second, because I know this might look very crazy. But if I have 9 to the 3/2, if I have 3/2, I really have 1/2, 1/2, 1/2. And I just told you, like, well, I didn't tell you, we figured out how we can find the value for 9 to the 1/2, right? So I can actually break it up. If I have 3/2, notice when your numerator is greater than 1, you can actually break out the exponent. So 9 to the 3/2 is really the same thing as 9 to the half times 9 to the half times 9 to the half. That's a property of exponents from last week, actually 2 weeks ago at this point. If I multiply a number, same base, I can add the exponents together. 1/2 and 1/2 and 1/2 gives me 3/2. So if I break it out, look at how I'm able to simplify it. We know that 9 to the 1/2 is 3. So this actually becomes 3 times 3 times 3, and I can calculate that to 27. So if you see a fraction, a rational exponent like that, where that numerator is greater than 1, there's a strong chance that you can break it out. So examples of this. 25 to the 3/2. How would I break that out?
25 to the 1.
Now, do we all see why we have 3 of them?
Yes.
If my exponent here was 3/2, I actually have 1 here, 1 here, 1 here. Do I know what 25 to the 1/2 is?
5.
It is 5. Because what number squared gives me 25? And the answer would be 5. So I have 5 times 5 times 5. Now, you can calculate that. 5 times 5 times 5 is 125. But if you ever break it out and you have a value that's so big, you could write it like 5 to the 3rd power when you're done. And you'll see some examples later on. I was looking through the textbook. There are a few practice problems where there's like 7/4 is the exponent. Like, I don't expect you to multiply whatever number 7 times. You can just raise it to the power, right, to make your life a little close. How would I break out 27 to the 2/3?
27 to the 1/3. 1/3 1/3.
What is 27 to the 1/3? 3. So I'm looking again, what number times itself this many times gives me that number? So 3. 3 times 3 times 3. So what is 27 to the 2/3? 9. Try 16 to the 3/4. Try it in your notebook and we'll do it together when you're done. Think about how you would break it up, and once it's broken up, can you find the value and then calculate? So these require an extra layer here. We have to break out that expression before we can simplify. Who wants to share how they broke out 16 to the 3/4? Ibrahim, go ahead. Good. So Ibrahima broke this out to 16 to the 1/4 times 16 to the 1/4 times 16 to the 1/4. Now what? Can I simplify 16 to the 1/4? What is 16 to the 1/4? 2. 16 to the 1/4 equals 2. That's 2. So now let's look at why this is 2. The reason it's 2 is because 2 to the 4th equals 16. We're looking for this number to this power would equal that. you're kind of like looking at it and working backwards, like repositioning the numbers around. But yeah, 16 to the 3/4 is broken out to 16 to the quarter, to the quarter, to the quarter. So that becomes 2 times 2 times 2, which is 8. So this is all about simplifying those exponents. A little different. There's a chance you would see a question with like a fraction exponent on the part. It's really considered a property of exponents. I don't recall there being one last year, maybe the year before, but I never was able to, we never got to this topic with the previous grade level, so at least it's something you see. We are going to build it in. Tomorrow we're going to work on converting between rational exponents and radical form, because we can rewrite this number just like you can rewrite this as a number in the radicand. Sorry, I'm like losing my words right now. So tomorrow we're going to work on converting back and forth between these methods, those forms. Okay. So what we're going to do for the remainder of the class period, and we have about 20 minutes.